Hello. Let's continue now with the analysis of the common base amplifier. Next thing, we're going to analyze the low frequency response in order to calculate the low cutoff frequency FL. And we're going to use the dominant pole approximation, meaning we're going to calculate the location of the low cutoff frequency or the pole due to each one of the coupling and bypass capacitors individually, and then we will consider the largest ones of those frequencies to be the dominant low cutoff frequency, and we will approximate the low cutoff frequency of the overall amplifier as being approximately equal to the dominant of the low cutoff frequencies. So let's get started. We have three capacitors, CB, CC1, and CC2, and therefore we are going to calculate three low cutoff frequencies. So low frequency analysis. First, we're going to calculate the low cutoff frequency due to CC1, so FL due to CC1. And each one of those capacitors forms a first order high pass filter, RC filter, with the Thevenin resistance or the equivalent resistance connected across the capacitor's terminals. So all those cutoff frequencies are going to be of the form of 1 over 2 pi RC, with C being the capacitor under study and R being the Thevenin resistance connected across the terminals of that capacitor. So 1 over 2 pi, and in the case of CC1, we can see that the Thevenin resistance connected across the terminals of the capacitor are going to be on one side RS. We're disconnecting, for purposes of calculating the Thevenin resistance, we're disconnecting the voltage source VS. And so that will be a short to ground. So it will be RS in series with the input resistance that we previously calculated, the input resistance looking into our circuit. So RS plus Rin times CC1. And this is 1 over 2 pi, 100 plus 180 times 10 micro, which is approximately equal to 57 Hertz. My low cutoff frequency due to CC2 is going to have the same form, 1 over 2 pi RC. In this case, R will be the Thevenin resistance associated with capacitor CC2, which will be RL in series with the output resistance of our circuit, which we previously calculated. So RL plus R out times CC2, which will be 1 over 2 pi, RL is 20K, R out we calculated it to be, RL is 100K, R out we calculated it to be 20K times 1 micro, and that yields 1.32 Hertz. And finally, my low cutoff frequency due to CB, it's going to be 1 over 2 pi. And now the Thevenin resistance connected across the terminals of capacitor CB, which we can see is going to be, on one side, CB is connected directly to ground. On the other side, we have, I'm actually going to write it, since we haven't calculated it before, I'm going to just express it as R Thevenin across CB times CB, and then I will calculate R Thevenin across CB separately. It's going to be R1 in parallel with R2, in parallel with the resistance looking into the base of Q1, which is going to be beta times little re plus RE1. And notice that when we are calculating the cutoff frequency due to one capacitor, we are ignoring the effect of the other capacitors, and so we are essentially shorting all the other capacitors. And so CC1 will appear as a short, which means this will be little re plus RE1 plus RE2 in parallel with RS. And again, our signal source is just disconnected or shorted to ground. So I have 220K for R1 in parallel with 20K in parallel with 100 times, and then little re is 50, RE1 is 150, so this is 200 plus And RE2 in parallel with RS is going to be 1.85K in parallel with 100, so it's approximately 100. And this resistance gives me approximately 12K. So now I can enter it into my equation, 1 over 2 pi, 12K times CV, which is 1 micro. And my cutoff frequency is 13.26 hertz. So my dominant low cutoff frequency can be approximated as the maximum of FLCC1, FLCC2, FLCB, which in this case is 57 hertz. Now we have seen that the larger the delta or the difference between that high cutoff frequency and the others, the better the approximation will be. In this case, 57 hertz, the next one is 13 hertz, so it's going to be a fairly good approximation, but we will expect that the actual cutoff frequency, will be slightly larger than 57 hertz. Thank you.